Hi there. Okay, so in this video, I'm just going to quickly go over algebra and equations as it is in the final grade 12 paper. All right, so this is just some exam questions that I took from the exemplar papers. So let's get into it quickly. Just please check out my Instagram page, Russell M Mathematics, and follow me on there. You can also drop me a quick email if you've got any questions or any inquiries about tutoring or anything of that sort. And if you find this video helpful, then please don't forget to like it, and don't forget to subscribe to this channel because I will be posting quite a lot of math content. And click on the notification button so that you can see what we're always up to. Okay, so let's get into it. Right, so we've got a first question here where we have to solve for x. Now, a common misconception is when most students want to try and factorize this as a quadratic trinomial. Now, it's got only two terms there on the other side of the equal sign, so that definitely cannot be a quadratic trinomial. So the best way to solve a question like this is, okay, so let's just write it down quickly. 3x squared minus 4x is equal to 0. As we can see, there's a common factor, is x and x squared, so that means we can take out the x, and 3x minus 4 is equal to 0. Okay, just as a note, if you still struggling with understanding factorization, I'm going to be creating new content that explains how to do this factorization. Okay, so don't you worry, or you can just quickly drop me a quick email or WhatsApp. The details are there in the description box. All right, but this is how factorization happens. Okay, so in this case, this means this is x times that, giving us naught. So according to quadratic theory, it means x is equal to 0, or this other term 3x minus 4 is equal to 0. So one of them is 0. Okay, so x is 0 here already. Let's solve that one to see what will be the value of x if this is equal to 0. All right, so we're going to say 3x minus 4. Okay, we're going to add 4 there. We're going to add 4 there. Okay, so that's 3x is equal to 0 plus 4, which is 4. Divide by 3 both sides, and x is equal to 4 over 3. Okay, so our final answer is x equal to 0, or x is equal to 4 over 3. Okay, right, let's move on. Okay, we've got this question here. All right, let's try to put that into standard quadratic trinomial. Okay, so that's question 1.1.2, where we've got x minus 6 plus 2 over x being equal to 0. Okay, so we need to get rid of the denominator there. What that means is that we're going to multiply each and everything there by x. Okay, so let's multiply that by x, multiply that by x, multiply that by x, multiply that by x. Okay, this is going to cancel out with that. So what we're going to end up having there is a little something like this. X times x is x squared. 6 times x is 6x plus, okay, so this is 2 is equal to 0. Okay, now we're going to try and factorize this. Remember how we factorize quadratic expressions. Look at the constant. Find two factors of the constant that if you multiply them, they give you 2, and if you add them or subtract, they give you negative 6. Turns out we will not be able to find that. Probably that is why they want us to leave our answer correct to 2 decimal places. Okay, so that is when we're going to bring in our quadratic formula. All right, so this is the formula exactly as it is on the formula sheet. All right, so let's make the substitutions into this formula. Okay, but before I do that, let's just remind each other quickly which one is A, which is B, and which is C. So A is the coefficient of x squared, B is the coefficient of x, and C is your constant. Okay, so in this case, our A is going to be positive 1, our B is going to be negative 6, our C is going to be positive 2. Now we're going to take this and substitute it into that equation that we have over there. Okay, so let's do that. So x is equal to negative of b, so that's negative 6 plus or minus the square root of negative 6 squared minus 4 by a, which is 1, c, which is 2. Alright, so that is under the same square root over 2 times a. So I'm just going to bring my calculator quickly. Okay, so let's calculate that. So that let's get negative of negative 6 minus the square root of negative 6 squared minus 4 by a, which is 1, c, which is positive 2, divided by 2 times 1. So we're just gonna enter that as it is. Okay, so our first solution is gonna come out as a third, but remember our instruction is to keep this to 2 decimal places. So we're gonna convert that to a decimal number, and we've got 0.35. So our first solution is x equal to 0.35. Okay, let's look for our other solution. Okay, so let's look for our other solution. We are just going to go back to our calculator, delete the negative, put the positive in, and equals. Okay, we have to convert that to a decimal number, so that is 5.64, which rounds off to 5.65. So the other value for x is 5.65. Okay, this is pretty straightforward, but if you're not finding it straightforward, then please contact me and we'll see how we can assist. All right, next one, it's an exponential equation, standard exponential equation there. X to the power of 2 over 3 being equal to 4. So you're gonna raise both to the power of 3 to the power of 3. Why? Because there's a rule of exponents which tells us that if this is the case, then you're going to say 2 over 3 times 3, because there's a rule of exponents that says you can't do that. Okay, so that just cancels out with that. So that means x squared is equal to 4 to the power of 3. You should get 64. Okay, so I'm going to have to take the square root so that I go back to x, but take the square root the other side also, so that we have x being equal to 8. And that is how we're going to solve that one. Okay, now question 1.1.4 is not your conventional inequalities, because I'm sure most of the time we'll be expecting to have quadratic inequalities in the exam, but it's not the case here. Okay, so we have our inequality 3 to the power of x by x minus 5 less than 0. Okay, now 3 to the power of x is a standard exponential function, so it's always greater than 0, which means this is always positive. Now, for us to get something less than 0, one has to be positive and the other negative. So if this 3 to the x is always positive, then that means this x minus 5 surely must be a negative. So x minus 5 surely must be less than 0. Okay, take the 5 over, and then x is less than positive 5. And that is our solution set. Okay, now we get to the simultaneous equations. Okay, so let's label these equations. So I'll label this as equation 1. I'll label that as equation 2. It's always advisable that you rearrange the linear equation. The linear, that's the one without the x squared. It's always easier to do it like that. So we are going to rearrange this second equation there. Okay, so let's take y over. So that becomes 2x equal to 2 plus y. Okay, let's make y the subject of the formula. So I'm going to take this 2 over. So 2x minus 2 is equal to y. Okay, now I'm going to take this and substitute it into equation number 1. Okay, rather let's call that equation number 3 because we might need to use it later. So we have 2x minus 2 being equal to x squared minus x minus 6. Okay, so let's take this over. So if we have a not there, that's going to be x squared minus 6. X minus 6. Okay, this 2x positive comes over, becomes a negative. This negative 2 comes over, becomes a positive. Okay, like terms, so negative x minus 2x will give us negative 3x. Negative 6 plus 2 will give us negative 4. Okay, let's see if we can factorize that. Yeah, we actually can factorize that quadratic trinomial, so that the factors of negative 4 that can add up to negative 3 is negative 4 and positive 1. Oh, and by the way, if you're still struggling to understand quadratic factorization, you're very much welcome to use the quadratic formula. Okay, so you can still use it and you still get your marks, so that shouldn't be a problem. All right, so from here we will find that this x minus 4, so x equal to 4 is in solution. X plus 1, so x minus 1 is a solution. Okay, now we're going to take these results and substitute them into this equation here. So into equation 3. So the first one, x equal to 4, we're going to substitute it into there. So that means y is going to be equal to 2 by, remember x is equal to positive 4, so we're going to replace positive 4 there. Minus 2, okay, 2 times 4 is 8. Minus 2, which is 6. Okay, we're also going to take this negative, substitute it into there. So y is equal to 2 by negative 1 minus 2, which is equal to negative 2 minus 2, and that should give us negative 4. So we have our solution set. Okay, the first solution set is the one where x is 4 and y is 6, and the other solution is where x is negative 1 and y is negative 4. Alright, so that is a solution to that pair of simultaneous equations. Okay, question 1.3 is one of those unconventional questions, but it just involves a knowledge of exponents and surds, and I'm just going to quickly show you how this works. So that is square root of 3 times, well, I can split 48 into 3 times 16. Okay, so 3 times 16 gives us 48. Okay, and here 4, well, you can just split that, and then 4 to the power of x by 4 to the power of 1 by the first law of exponents, all over 2 to the power of 2x. Okay, now according to our rules of surds, you can do something like this. where we can take that square root of 3 on its own and multiply it with the square root of 16 on its own. Okay, 4 is the same as saying 2 to the power of 2. Okay, so raise that to the power of x by 4 to the power of 1, which is 4 itself, over 2 to the power of 2x. Okay, square root 3 times square root 3 just gives 3 itself, times square root of 16 gives us 4, okay, put it times. Okay, according to our rules of exponents, that is going to become 2 to the power of 2 times x, which is 2x, by 4 over 2 to the 2x. Okay, now this can divide each other out, and we have 3 times 4, which is 12, minus that 4 that is left over, and the answer to this is equal to 8. Okay, so that is how we are going to solve that one. Alright, question 1.4. So we're given that f of x is equal to that. I think you can already pick up that this is an equation of a standard parabola. Okay, and g of x is equal to 3. Now here's the question. Is it possible for f of x to be equal to g of x? And we must give a reason for the answer. Okay, let's check something here. F of x is what? This thingy. So 3 x minus 1 squared plus 5. Okay, but as you can see, this is the equation of a standard parabola, which means the turning point of this parabola will be x positive 1 and y positive 5. This is the minimum turning point. So as you can see, this is the minimum of this function. So the minimum for f of x is going to be positive 5, which means this function cannot go lower than 5. But now, g of x is equal to 3, which means it's a horizontal line that's going to be 3. So obviously, these graphs are not going to meet, right? So, how do we write our answer? So no, f of x not equal to g of x, because the minimum value of f of x is greater than 3, so they cannot meet. Alright, so that is why f of x cannot be equal to g of x. Okay, now we need to determine the values of k for which f of x is equal to g of x plus k has two unequal roots. Okay, so we have to pay attention to that, two unequal real roots. Alright, now let's first of all write down the equation f of x being equal to g of x plus k. Okay, so f of x is 3 by x minus 1 squared plus 5. G of x is 3 plus k. Right, now we want to rearrange this and make it and write it as a standard trinomial. Okay, so I'm going to take this, expand here. So this is x minus 1 by x minus 1 plus 5, which is equal to 3 plus k. Okay, so we're going to use our first outer inner last expansion there. Okay, so that's x squared, that's that, and that's that, and that's that expansion. So we're going to have 3 x times x is x squared minus x times 1 is x minus 1 times x is x plus, because 2 negatives multiply together, so plus 1 Okay, so plus 5. So rather, let's bring this over to this side. So minus 3 minus k is equal to 0. Okay, let's expand that. So that's 3x squared minus 3x minus 3x, because the 3 is multiplying inside, plus 3 plus 5 minus 3 minus k is equal to 0. Okay, so we've got 3x squared. So negative 3 minus 3 is negative 6. That's negative 6x. 3 plus 5 is 8 minus 3, so that's positive 5. So plus 5 minus k being equal to 0. Okay, now we're going to calculate our discriminant. Remember this formula, delta is equal to b squared minus 4ac. Okay, so we're going to calculate our discriminant there. We need to determine our values of a, b, and c. Okay, so there is a, it's 3, there is b, it's negative 6, there is c, it's 5 minus k. Now let's substitute that into the formula there. So as we said, b is negative 6, so that becomes negative 6 squared minus 4 by a is 3, c is 5 minus k. Alright, let's quickly simplify that expression. So that's going to be 36 minus 4 times 3 is 12 by 5 minus k. Okay, let's move the brackets here. So 36 minus 12 times 5 is 60. Negative multiplying with a negative makes a positive. K. Okay, 36 minus 60, that's going to be negative 24 plus k. And now let's go back to our question. This is values for which this has two unequal real roots. So in that case, when roots are unequal and they are real, our delta is greater than 0. So which means this thing here is supposed to be greater than 0. So negative 24 plus k must be greater than 0. Alright, take the 24 over. So k becomes greater than 24, and that is the values. Okay, right, so this is question 1 from the 2014 Exemplar paper. If you found this helpful, therefore don't forget to follow my Instagram page, SLM Mathematics. You can drop me a quick email or any other inquiries, or you can even just write to the comment section. That is still welcome. And if you found this helpful, then please like the video, please subscribe to my channel, and click on the notification button. And I hope to see you in the next video. Thank you for watching.